at I feel like at this point, a lot of this research might not change the like practically what we're doing in the gym, but it helps us understand why we're seeing what we're seeing in the gym. Um, would you agree with that, or do you think we're really getting some, you know, practical advice from these studies? Are we really going to be able to take away and change what we're doing in the gym from the results of these kinds of studies?
Well, yeah, I mean, I hope so. That's kind of the point for us. Well, Dr. Roberts' lab is called the Molecular and Applied Science Laboratory. So
Mm.
the slogan for the lab is bridging the gap between molecules and man. So the idea, right, is that we can use molecular biology and studies like this to chase mechanisms, but eventually we want to apply those in the practical setting, right? And we want it to help people um, reach their fitness goals or improve their health. So yes, I absolutely think that the outcome of these studies will eventually be um, that some of the information that we can glean from the studies can be applied in some way. But let's just stick to sarcoplasmic versus myofibrillar hypertrophy as an example.
Hmm.
Let's say that in this study, we find that the leg that trained with higher intensities on average um, accrued more myofibrillar protein, and that occurred alongside increases in strength, whereas the other leg didn't accrue as much myofibrillar hypertrophy or myofibrillar proteins and perhaps more sarcoplasmic proteins, and that leg didn't improve in strength as much. So, what do we do with that information? Well, I think practically speaking, if you want to get stronger, that probably involves the accrual of myofibrillar proteins and lifting higher intensities on average.
Hmm.
So, I mean, I think that's a very practical way of bridging the gap between some of these molecular assays and practical outcomes. So, what
Yeah.
would you say to that, Doc?
I agree. No, Cody summarized it well. And there's a study I showed Van yesterday, and you've probably seen this, but they had older people lifting at around 55% 1RM. So that's what Cody and Van did. And they did that for 24 weeks. Then they took a 48-week hiatus from lifting. Excuse me. So they had one group do 55% 1RM for 24 weeks. The second group did around 80 or 85% 1RM for 24 weeks. So it's parallel design. And then they had them take a hiatus for 48 weeks and retested their strength. And to Cody's point, those that lifted the heavier weight still maintained strength above baseline, whereas the group that lifted 55% 1RM after that 48-week hiatus, they were back down to baseline.
Mm.
Usually neural adaptations are very rapid, so I
Yeah.
don't think that that's a 48-week hiatus in terms of lingering neural adaptations keeping the high intensity groups stronger. And so I think
Mhm.
to Cody's point, that could be because of 24 weeks of high intensity training elevated the contractile protein component.
Yeah.
That's
Just
that's our
did I hear that
hypothesis.
right? That you said after 24 weeks they took 48-week hiatus,
That's correct.
and they were still above baseline after that long?
Yeah, and it was pretty robust. I mean, it
Wow.
was. I can send you that paper,
Yeah. Yeah.
and it's pretty. I don't know if you have show notes, you can post it, but
Hmm.
at any rate,
Yeah.
I mean, it was especially for the legs, it was very very well elevated. So yeah,
Wow. And this was an older population as well?
this was in older people. So I think on average it was 70 years old.
Oh, wow.
Yeah.
That is actually pretty surprising to me. That's cool.
So in response to Cody's point, like the broader when you start talking about resilience to frailty,
Hmm.
sending the message that you don't want to lift neon dumbbells to failure because if you
Right.
happen to get injured or whatever, especially in that age group,
Mhm.
that could be counterproductive, right? That's kind of the
Right.
idea.
Yeah, and I think that's a great example because my not counter argument, but I guess like playing devil's advocate to what Cody had initially said, you were saying, well, if it shows us this, and
Yep.
I would say that's kind of again showing the mechanism behind it, but nice trio there.
Yeah.
um, but like again, that's showing the mechanism. But I think most people kind of know and have known for a while that lower reps, tend to result in more strength gains. But that's a great example, Dr. Roberts, where it's like, okay, well, now we're showing that for like an older population, we can actually apply that. And maybe if they're not going to be super consistent, or even if they think it's just going to be for a certain period, that might still confer benefits long term for them, even if they're not always super consistent with it. So that's a great example.